In this video, I'm going to teach you about the Claisen condensation reaction. Formation of ethyl acetoacetate from ethyl acetate in the presence of sodium ethoxide is an example of Claisen condensation reaction. Formation of ethyl acetoacetate. Ethyl acetoacetate CH3CO CH2COOET. Ethyl acetoacetate from ethyl acetate. In the presence of sodium ethoxide is an example of Claisen condensation reaction. Here, two molecules of ethyl acetate reacts in presence of sodium ethoxide, and in the second step acidic workup to provide ethyl acetoacetate. This is ethyl acetoacetate. If you look at this molecule with respect to this ester, this is alpha carbon and this is beta carbon. So this is a beta keto ester. Beta keto ester. In general, it is a base catalyzed condensation reaction of esters having alpha CH2 group, forming beta keto ester. The general reaction can be written as RCH2 COOET. This is an ester which has alpha CH2 functionality. This reacts in presence of base in the first step and in the second step acidic workup to produce beta keto ester. So two molecules of this ester gets condensed to produce this beta keto ester. This is one molecule component and this is the another molecular component. Okay. So what is the mechanism of this reaction? The reaction proceeds in 4 steps. Step number 1, I am giving the reaction mechanism with this first reaction with the ethyl acetate in presence of ethoxide. This is a reversible reaction where the equilibrium remain mostly in the left side, that means in the starting material side. Why this is so? Because this proton has pKa of about 24, whereas ethanol has pKa of about 17.5. Since ethanol has lower pKa than ethyl acetate, than the proton of ethyl acetate, so the equilibrium remains in the left side, that means the starting material side mostly. In the step 2, ethyl acetate gets condensed via this type of nucleophilic attack. And this reaction is completely reversible. In third step, this proton is being abstracted by ethoxide anion. To make a salt. Plus ethanol. Here pKa of this proton is about 11, whereas pKa of ethanol is about 17.5. Therefore, this reaction at the step number 3 proceeds towards the right side, that means equilibrium mostly remain in the product side, and this is the successful step of this reaction. Therefore, to make the reaction successful, salt formation is very much important. This is the salt formation step. And in the step 4, acidic workup to give neutral beta keto ester. This is step 4. CH minus. This is acidic workup step. Therefore, as you can see, this alpha CH2 group of the ester is very much important to make the reaction successful. Why 2 proton is necessary? Because 1 proton will be utilized for condensation reaction and the second proton will be utilized in the step number 3 to produce the salt, and by producing salt the reaction becomes successful, as this is the only step where equilibrium remains in the product side. Therefore, we can conclude here that esters of the type R2CHCOOET, this is ester where we don't have alpha CH2 functionality. Okay, here we have only one CH, not CH2. Okay, so this type of esters does not do this type of esters do not react Claisen, in Claisen condensation reaction in presence of ethoxide base. Here it is important, in presence of ethoxide base to produce R2CH you see why this will not occur, because we have seen in the mechanism that in this carbon proton is necessary to make salt, which is the successful step, but if there is no proton this will not produce a salt. A salt is formed by abstracting proton from this carbon. Therefore, this reaction, this ester R2CHCOOET will not undergo Claisen condensation reaction in presence of ethoxide anion, ethoxide base. However, we can make the reaction successful. That means the reaction of R2CHCOOET, we can make the reaction successful by using a strong base. A strong base B minus, which has pKa of its conjugate acid more than 24. Why? Because if the pKa is more than 24, you see here, if we use a base in the first step, okay, in the first step, if we use a base whose conjugate acid has pK more than 24, then at the very first step the reaction will be driven towards the right side. That means we will get the product. Moreover, since the base has pK of the conjugate base is 24 or more, then salt formation can also occur by abstracting a different proton, that is R2CH C double bond O CR R COOET. This is forming in the step number 2 of the reaction mechanism, right? So in the step number 3, salt formation step is present. So base will abstract this proton now because it is very much strong base. So this strong base can abstract this proton to make salt R2C minus. So this is alpha, beta, gamma. So salt formation occurs by abstracting gamma protons. By abstracting gamma protons. Alright. Now I'll give you one problem. So far we have understand the Claisen reaction. Okay, here I forgot to mention some bases which has this character, that means the conjugate acid has more than 24 pKa, and such bases are NH2 minus, pKa of conjugate acid is ammonia is 33. This is base number 1. pH3C minus, this is also a very good base because pKa of pH3CH is about 31.5. These are very good bases and very widely used in Claisen condensation reaction. When we use these bases, I mean very strong base, that time we don't need alpha CH2 functionality to make the Claisen condensation reaction successful. So this is only applicable when we are using ethoxide as base. Now the problem is, let's say we have this ester CH3 C double bond O O pH. Now we are giving phenoxide PHO minus as base. The question is whether the reaction will occur or not. This is a Claisen condensation reaction. We may expect Claisen condensation reaction. Now we have to analyze step by step with the help of pKa value to understand whether the reaction will occur successfully or it will remain, the equilibrium will remain in the starting material side. That we have to analyze. Step number 1. CH3 OPH plus phenoxide. This is equilibrium phenol plus CH2 . Alright, now step number 2. This reaction will mostly remain in the starting material side as the phenoxide is not that much strong base to abstract this alpha proton. Phenoxide is not a very strong base because its negative charge is resonance stabilized by the phenyl ring. Step number 2, CH3 OPH. Now this anion will react with another molecule of the ester. This reaction will remain completely reversible as the energy barrier is very high and both sides the stability is almost very similar. Alright, now the important step is the salt formation step. See, ethoxide is much stronger base than phenoxide. Ethoxide, ETO minus. In the first example we observed that even as ethoxide is stronger base, even it is a stronger base, it could not drive the reaction towards the right side. Only the salt formation step helped that in that case to make the reaction successful. Here we are using phenoxide. It's much weaker base. Therefore, it cannot drive the reaction towards the right side if the salt formation step does not occur. Now this is very important to analyze. This is the salt formation step. This alpha proton will be abstracted by phenoxide. Now we have to see what is happening in this case very carefully. Plus phenol. Okay. Now we have to analyze the pK values. See, this pKa of this proton is about 11. Okay, pKa of phenol is 9.95. That means phenoxide is a weak base, whereas phenol is a strong acid. Okay, and this is weak acid. The pK values indicate this information. Okay, and this is strong base. Therefore, as it is weak acid, it is reluctant to give proton, whereas it has to be a strong base, but unfortunately phenoxide is a weak base, therefore it cannot abstract this proton to make this salt. So the reaction will remain unsuccessful. The reaction will remain unsuccessful. Nowadays, ethoxide is replaced by sodium diether. We do not use equivalent amount of ethoxide nowadays. Instead, we use sodium diether and 1 drop of ethanol. Because do you know why? See, we are having problem to drive the reaction towards the right side. Let me open the first example. Okay, this is a reaction of ethyl acetate in presence of ethoxide. Okay, so we are struggling to drive the reaction from left to the right side, and you see that ethanol is forming in the right side. Now in the reaction, if we use ethanol in large excess, then it will be more difficult to drive the reaction towards the right side. Therefore it would be better to use a small amount of ethanol so that the equilibrium goes to the right side. Nowadays, ethoxide is replaced by sodium diether and 1 drop of ethanol, very small amount, because in step 1, ethanol is one of the products. When ethoxide, one of the products which disfavor the reaction to proceed to the right side. Right side means to the product side. This is all about Claisen condensation reaction.